I have a first question concerning carbon capture on board of ships. So I think I'll direct that to Maria, because I think that's probably linked to the HIMETH ship project. Whether you have looked into the costs of carbon capture on board ships.
Thank you so much. I can't get my video to start, but you can bear with my just voice then.
Yeah. Okay.
Well, now it is loud. Okay.
Yeah.
So see you here. Can you repeat the question, Sebastian?
Yeah.
Sorry.
So it was referring to the HIMETH ship project, I think, concerning the cost associated with the onboard carbon capture. Whether you have already looked into that.
Good question. I should have that in top of my mind as well. I did check the other questions that I got during the first part, but I didn't open up this HIMETH ship paper. I have to come back on that. Sorry.
Yeah. Do you know how or what type of technology is used there for the CO2 storage?
The CO2 storage itself, I don't know if that is a special one, but I think that is common, that you have to have it in a liquid form. You need to cool it down. So you have a storage on board for the CO2. Yeah. So that you can have it. Oh yeah, we have Jens.
Yeah,
maybe we can add something to this.
Yeah, go ahead, Jens.
Yeah, we've ran into a number of different capture companies, and one gave us an overview that they use membrane contactors because one of the issues is the large plot space that you need for a typical amines scrubber. And so in their case, they would use membrane contactors, and they would put traditional amines capture in containerized units specifically developed for ships. So I can pass on. I don't want to advertise for these guys, but if you contact me, I can pass on the contact details.
Great, thanks. Then we have a question that I think will be directed to Christian, which is about existing direct air capture installations, where the thermal energy required for the carbon capture actually comes from.
Yeah, so it has to come from somewhere. So you need to provide some energy source, and it can be concentrated solar heat or some other way, and it's normally transferred using steam. So allowing steam to condense on the system and then dry out again. And with respect to the previous questions, I know that also other amine type companies have worked with traditional capture systems, but that allow for tilting environments like the ship rolling in waves and stuff, which is pretty cool.
Indeed, yeah. I have a follow-up question for you, Christian, and that refers to the distance problem, in the sense of where CO2 is emitted and where it is captured. And do we assume that it will mix due to climate effect? So maybe I'll give a small twist on that. I've heard people ask about, well, if you just take carbon from the air, what's going to be the consequence of that? I think you refer to it in part. Maybe you can come back to that.
No, I mean, there is going to be a shortage, local shortage of CO2, and that will affect growth rates and stuff if you have plants close by. So the lands that are positioned directly after a direct air capture unit will have to be used for something else than growing. It's going to be depleted with CO2. So yeah.
Thanks. Then I have a question on e-fuels production. Maybe I'll first direct this to Maria. It's about the need for water, and that's scarce. So whether you have any insights into the energy costs of desalination of seawater before you can do electrolysis, because that is a much bigger source of water, of course. And I see a couple of people nodding, but I would suggest, Maria, that you take this first.
Yeah, I think that you will get a direct answer more from the technical guys in this here. But I say that it's a good question, and I just want to say that the size of water, the need of water that you need for the electrolysis, that probably it occurs, of course, when you have where the solar is. If you have it in the Middle East or if you have it in the desert, you need the water, the fresh water there. So then you need the desalination. But on many places around the world, that there's no big issue around the water shortage, and the amount of water that you are using, it also comes out again. So it's in the circle. You're not converting water into something that is
Yeah.
not again coming out again.
Yeah. And maybe
the desalination is an important issue, and for those the desert and then the Middle East areas, that could be really important.
I did see you nodding, Christian. Is there something you would like to add to this?
Yes, I was just going to say that it's perfectly all right to do electrolysis of salt water. The problem is that you will get chlorine instead of oxygen. So you will get your hydrogen, but you will get chlorine gas as well.
Yeah, and I think Jens has to add to that. So over to you, Jens.
Yeah, it's not always a problem that you get chlorine. Some do it on purpose, like we do. No, but also the benefit of one of the reasons we looked into the methanol synthesis is, you produce water as a byproduct. You have to purify your methanol anyway, so you can recycle that water. The other aspect is coming back to the question before on the energy required to run the carbon stripper. You have a lot of excess heat from the methanol production itself, so you can do heat integration. Of course, you also need to run the distillation trains to purify your methanol, but water recycling and energy recycling is very beneficial in combining carbon capture and methanol synthesis.
Okay, thanks. Then we have a general question, but I will direct that to Ingvar first. What about renewable production versus legislation or incentives? So maybe some insights into the possibilities with the RED II directive. What are the main features and the implications they could mean for methanol?
That's not that easy to answer straight away, I would say. I mean, methanol in general has not had a position as one of the key alternatives when going to renewables, and this seemed to really be changing in the current few years. But as we all see, and I've heard from many of the speakers this morning, it's an interesting situation we have, that the methanol solution for many is the cheapest and best one, but it's not favored. And this was very clear in the SCAB report when we worked with the infrastructure directive. The infrastructure directive was ready in December 2014, resulted in sustainable fuel forum in 2015, from which then this SCAB group originates as a subgroup. And as I'm sure you're aware of, there was 4 systems which was then advocated by the infrastructure directive. It was LNG, CNG, hydrogen, and electricity. And biofuels was kind of pushed aside. And if you then go to biofuels, did not have anything about methanol. It was really HVOs and so on, which are very limited, as you know, in resources. So the whole biofuels arena has been handled in a very kind of as a side dish, you know. Yeah. So therefore it's difficult to answer your question, really. I've been working with this for kind of 3 decades. Yeah. And I know the possibilities. And I think now with the e-fuel coming up and the idea of actually being more careful with the carbon coming from the bio source, I think can become a very, very vital source for cheap methanol production, fairly cheap methanol production. While I see, as Jens showed, on the cost of just the hydrogen, to get to the e-methanol that will kill the system. You will have problems to get cheap power to get the hydrogen cost down. Yeah. But it's a bad answer. But I think that's realistic. I mean, we have been working on the long-term support for various type of renewable fuels in our country and in many other countries. And I'm sure you know, all of you there, that it's a long-term legislation for a change you need to be able to build various kind of renewable type plants, regardless of what product you select, actually. So.
Yeah, thanks, Ingvar. I think Jens was first to want to add to that, so I'll turn it to Jens.
Yeah, just 3 quick data points. We worked with the large methanol traders, and we kind of ran the scenario: what happens if RED2 would accept e-fuels like e-methanol? What would be the market value? The numbers we got back were in the range of 1,000 to 1,200 euros per ton. That's based on the avoidance of the penalties if you don't meet your criteria. So I think the concern around biomass, food or fuel, this whole concept is partially addressed by proposing that the 14% is split into at least 7% non-bio based. So they are addressing that. And then the last part of that is I think the discussion we have, at least in Germany, I sense that, and that's my personal opinion, there seems to be a concern that if you allow synthetic fuels, that you reduce the pressure on e-mobility conversion. That seems to be a bit the fight between the environmental ministry and the economic ministry, while in reality, I think we need probably a certain period where we have to bridge conversion, because nobody's going to, I mean, not 90% of the people are not going to throw away their car tomorrow and buy a new electric car. And so
Indeed.
there's a growing acceptance of synthetic fuels, e-fuels, being a bridging solution for normal transportation, and then for heavy trucks it may be also, and for ships it may be a long-term solution. So I see growing support, and if it happens, it immediately makes these things economically viable.
Thanks, Jens. Maria, you had something to add?
Yeah, I found some numbers just in case you are interested also in some numbers. We had a fast calculation done actually yesterday on this. So we needed 12 kilo of water for 1 kilo of hydrogen. That meaning if you have a desalination and energy consumption about 10 kilowatt hour per cubic meter, that would result in an increased energy of about 0.1 kilowatt hour per kilo of hydrogen produced. So that's a lot of numbers, but it's just saying that it is a part of it, but it's not insignificant, of course. So that you will add some energy and add some costs to the desalination part.
It will not affect your overall conclusions.
That's right.
Yeah. Okay. Great. Then we had this question actually for the morning session, but it equally applies to the production side. The question being, if they are missing, where are technology providers missing? Or is something else missing now? So I'll pass this around. The conclusion this morning was like, no, technology-wise, it's fine. It's other problems. So do you agree with that for the production side? And maybe I'll start with Christian.
Sure. I mean, I do not agree that it's all wonderful and perfect on the technology side. I think that we still have some homework to do in some aspects, especially on perhaps on integration. But the main issues that I see outstanding is the traditional ones with respect to scale up and the cost of scale up. The good thing, especially focusing on methanol, is that we have a lot of existing plants where we can utilize the same platform. And so as long as we get to syngas, we can capitalize or cannibalize, or whatever word you want to use, that can integrate with these existing plants.
Yeah, thanks. Ingvar, same opinion or a different one?
No, I would say that there are plants under construction to produce hydrocarbons in the US, in Red Rock Biofuels, in another one, I can't remember the name now, but two major projects coming up in the US. We have the Enerchem company who converts MSW to methanol and ethanol. And we have developments which are not, they are very advanced development plans, but not scaled up, like black liquor gasification, which I'm working with, and also biomass gasification like GTI in the US. So I would say that if the incentive would be there, as we talked about in the previous question, there are definitely technologies. And you know, the rest of the game, I mean, to take the syngas and clean it and get it to methanol, that's proven. So yeah. It is a gasification unit. So in the report we are producing now, coming out in a month, I have put a lot of energy into listing the gasification technologies and their maturity. And they are on TRL 8, 9, really, 7 to 9. Yeah.
Okay. And I think we can probably go to the next question. And that is about the likeliness, and maybe I'll throw that to Maria in a minute, the likeliness of e-fuels being important from other imported from other continents? Will it make economic sense, for instance, to produce e-fuels in the Middle East where we have abundant sun and then ship them to Europe? How do you see that evolving?
I think that the discussions are already there. When I go to electrofuel conferences, we can see that the interest is there to find from Algeria and from the agreements between Europe and North Africa countries to start producing electrohydrogen or electrofuels on site and then ship them to Europe. We also find interest, of course, from the European actors to find where are the cheapest electricity spots within Europe. So we built some. I know that there are some discussions, at least, to build something in Norway and also in northern Sweden. So when you can find the business case where you have cheaper electricity, that's an interesting way forward. But we also see, of course, challenges when it comes to how to define electrofuels when it comes from policy side. So I think that it's a very smooth differences between adding hydrogen to a gasification plant and you have a part of that as a hybrid fuel or an electrofuel, or if you have a biofuel that you know that you add hydrogen as HVO, hydrotreated vegetable oil. So where are the differences? And since it's not treated equally, at least not currently equally, and it's a framework also developing around these type of fuels, the electrofuels. So that's a bit of homework to do when it comes to how to define the fuels, the policies, and how to go for the cheapest electricity spots. Yeah, it is.
Thanks, Maria. Then we have a question. I think that Jens could possibly take this on your thoughts on flexible methanol production. Say in response to changes in electricity price, can you start up, ramp down? Does this help with the business case for green methanol? What was the potential there?
Yeah, as I said in my presentation, the main issue there is that the capex for the electrolyzer is pretty big. So if you have intermittent production, you basically need to build larger capacity so you can catch up and get to an average quantity. So you're underutilizing your electrolyzer, which is not good in terms of capital investment. But definitely it's something that needs to be looked at, especially if you look into not so much day and night variability, but summer-winter variability. That's why large gas producers are looking into using salt domes, for example, to store hydrogen for seasonal balancing.
Yeah. Great, thanks. Then we have a question directed to all of you, namely on the measurements that you would suggest governments should take for moving production from fossil origin to renewable origin. What type of measure do you think would give the biggest impact? And Christian, maybe I'll start with you.
Oh, well, longevity. So having long-ranging incentives in place, not changing every 2, 4, 6 years with changing politicians. That's to me is something that we really need to get in place to make this fly.
Thanks. Ingvar?
Yeah, I can just repeat what Christian said. I mean, it's a long-term legislation. I mean, in Sweden, we have had this type of legislation, but not long-term for 25 years. It's taken every year, basically, the decision, which doesn't really help you when you're going to invest. So if we could get that kind of incentive we have today, put on the more promising fuels, then there would be plant builds straight away. But without that long-term legislation, it won't happen. It's just so, it won't happen.
What else besides long legislation, Ingvar? Can you think of some second one?
Of course. Then there is a combination of lobbying and information about pathways and ways forwards, for sure. I mean, when we have, I mean, I raised a question which was not taken up by you, Sebastian, but I can just mention it. I mean, Volvo and Daimler. Mm-hmm. They have put down, they say they're going to put 2 billion euros in fuel cell development for heavy duty vehicle developments. And I talked to people in the engine department of AB Volvo, and they are kind of, I shouldn't say upset, but they're kind of questioning, we're going to run the trucks with big hydrogen tanks on. And I asked them, why don't you go for methanol and reforming and actually get, as we have heard today, and which is old technology. It's done by Daimler in the 90s.
Yeah, indeed.
But I haven't gotten an answer yet. I mean, but that I think is talking about ships here. But for me, methanol fuel cells, because Volvo and Daimler has done this big announcement, why not approach those guys? And of course, that's an obvious, interesting. But it's lobbying, and in some way, and I think I've been working with methanol for all these years, and I think the simple answer is there is no heavy-duty champion company like an energy company promoting methanol. They don't like it. They want to go other ways. It differs from the 80s when we had the oil crisis. Then the oil companies, then they took the lead, and then it happens.
Yeah.
But if they are not in, it won't happen. So I think that's the main reason.
Yeah. Okay. Then I'll ask Jens. What are your ideas on what governments should do, or what will potentially have the biggest impact on this?
Yeah, a couple of things I mentioned in the presentation. First of all, carbon capture and use has to be credited against the ETS scheme. I mean, if you capture your CO2, you convert it, and you still have to pay the emissions, then no company is going to do that. That's a requirement. The comment that was mentioned about subsidies or any kind of regulatory framework needs to be predictable for the investment period of a plant. I mean, if we get a one-time subsidy, great, but if you talk about even OPEC subsidies, typical investment calculations are 10, 20 years for a chemical plant, and if you can't rely on these things to last even for the next election, then that's not going to fly. So I think changing things like RED II to put this kind of synthetic fuel in a market with a guaranteed return that justifies the investment is probably the wisest thing they can do. But again, CCU regulatory changes on ETS systems need to happen. And the other part is, we didn't touch on that today, but we also look into putting methanol through an MTO, methanol to olefins, to make maybe polyethylene and polypropylene and all these chains that are built on C2 and C3 greener. If you mandate certain quotas in that space to come from recycled or renewable material, that could also be a driver to establish a market price. In the end, you have to gap the bridge between the high production cost and the low market acceptance currently.
Thanks. Maria, do you have a different view on what governments should maybe do first that will have the biggest impact?
Well, from the environmental policy research area, we are all aware of that a global CO2 tax for fossil fuels would be the most cost-effective way forward to get all the renewable alternatives competitive. So, but then you have a lot of different obstacles before you can get the global CO2 tax on board, or a fee. But we have the ETS system, and or the credits that it can be a part of it to get the fossil fuels more expensive. I would say that in Sweden we have the reduction quota. So the reduction quota is one way forward, so that the fuel companies on their responsibility to blend in renewable components in a certain quota. So I think also other countries have the similar or volume-based or reduction-based. I think that is the way forward, although they also have some challenges when it comes to 100% of the, it's mostly applicable on drop-in fuels, but more difficult when it comes to applications when you want 100% renewable fuels. But it's different way forwards, and you test and try and complement different policy instruments. I think that is a way forward.
Okay, thanks. Then we have a question that sort of links up the morning with the afternoon session again. We touched upon this morning. If you look at methanol production, there's mostly still some water in there. It depends on the source, whether you go the bio route or the E route, but you end up with, let's say, raw methanol. Do you see a potential use for raw methanol being more interesting, for instance, to be able to offer to shipping from a cost perspective? Maybe Ingvar, I'll start with you.
I have one comment on the raw methanol, which I'm not fully, I don't know the technology all the way through, but I know in PTO, when we ran the black liquor to methanol to DME, we actually converted the methanol to DME on raw methanol. So you avoided the big distillation of methanol, getting rid of the water. And it's much, much cheaper and simpler to distill DME than methanol. So, and the reaction from ethanol to DME is almost, I mean, it's just 1% loss or something of energy. So the energy in the DME is basically energy in methanol. So and that was the reason Volvo supported that. So that was a simplicity there. And then we had to talk with Stena a lot about if you could take actually water-containing methanol, avoiding this grade AA quality methanol.
Indeed, yeah.
And Stena had no problems with it, but we had some problems with Wärtsilä because they felt unsecure about small amounts of water and corrosivity and so on. And I appreciate that. There are papers on those kind of things.
Yeah.
But talking to MAN, I think it was so, they didn't have an issue on that. So I think that is an interesting observation, that you can take in methanol with water. And I would like to add, if you go to the Nissan automaker, they run fuel cell cars on reformed ethanol on cars. And they blend the ethanol with 1/3 of water in the reformer before they get the hydrogen out to the fuel cell. So of course, if you have methanol with water or ethanol with water, the Nissan system seemed to be an interesting way forward for fuel cells.
Yeah, indeed. For some fuel cells, indeed, it's actually good that there's water in there.
Yeah.
But indeed, coming back to the discussion this morning, there's this inherent challenge, of course. Maybe technically speaking, it's interesting, but putting yet another fuel standard out there, that might be quite challenging.
That's true.
Yeah, things to look into. Maybe a question for Christian concerning the production of more complex fuels. And the question here specifically is about jet fuel. The production of that, does that run through a methanol route, or is that a different type of route? Is there so what's going on in that sense, producing fuels for aviation, let's say?
There is a route via methanol, so methanol to dimethyl ether and then on to ethylene, which can be oligomerized. It can also be over the CO hydrogen via the Fischer-Tropsch route to aviation kerosene. The yields are, however, smaller for the Fischer-Tropsch, I would say, to the right fraction. So it's all about what you can do with the rest of the interesting hydrocarbons that you form.
Yeah, great.
That are not specific.
Thanks. Then maybe one for Jens. Would the business case for hydrogen production look different for a chemical plant that needs to buy in electricity and a power producer, which is using surplus electricity to produce hydrogen to avoid negative electricity prices?
Yeah, that's an interesting question. We obviously looked into that as well, being such a large power consumer, whether we could play in the balancing market, in the spot market, and buy electricity. Given current electrolyzer prices and the efficiency around the cycle, I mean, hydrogen production is 70% efficient, and then converting it back to power is even less than that. So around the cycle, including the CapEx, it didn't seem to be a viable option to build and justify the CapEx, even with negative prices at a fraction of the time. But definitely, I mean, whether you do it as a power producer or as a chemical guy, it's just who takes the margin. So it doesn't really change the overall picture. The CapEx really is the issue, and the short periods of time where you have a negative margin.
Okay, thanks. Then I had a question on electrolysis versus scalability. We've mostly been mentioning PEM electrolysis, which means platinum, of course, as a catalyst. So are there any scalability issues there? Are people looking into alkaline technologies there? Could you compare the two? Jens, go ahead.
Yeah, I mean, we run alkaline technology in the chlorine envelope, and we have compared it to PEM for on-purpose hydrogen production. The capex is much lower on an alkaline electrolyzer. The efficiencies are not that far apart. So from a capex perspective, it's definitely interesting. Also, we are working with a couple of companies that have interesting developments in high pressure hydrogen generation, up to 300 bars. And that's something that avoids a lot of capex for the compression later on. So alkaline technology seems to be okay there as well. In terms of materials, yes, PEM has some scalability issues with the materials, but we expect that the electrodes are going to be less demanding on materials in the future. But for now, I think alkaline would be cheaper and easier to scale.
Yeah. Okay, great. Thanks. Then what I'll do to finish this off is just give each of you another minute to just get things off your mind if you still have issues that you haven't been able to put out there. And maybe Maria, I'll start with you. I know that there was one point right at the end of your presentation that you had to be a bit quick on. I don't know if you want to come back to that one or if there's another point that you would like to finish this with.
Well, I can start with just correcting myself, because I did a guess on what type of what efficiencies we had assumed in the comparison analysis that we have done. So the efficiencies that we have used in base case, I would just say them now. So 4-stroke engines, 40% efficiency, and the 2-stroke engines, 45%, and the fuel cell systems, 55%, and the battery electric, 80%. So then I just got the numbers right, since I was a bit of guessing when you asked me that question before. And yeah, the last slide in my presentation, that was one when we realized that the concept of cost competitiveness of electrofuels in an energy systems perspective, it's very much depending on the availability of carbon capture and storage, if the purpose is to meet the climate target at lowest cost. So it is cheaper from an energy system perspective if you want to really get quick into the 2 degree, below the 2 degree target, and aiming for even lower, if you can capture the CO2 and then store it. So that's the balance between capturing the storing and utilize it, the CCU concept, and the balancing of capturing the carbon and then store it, so the CCS concept.
Yeah. Sort of
but since we face some issues when it comes to acceptability for a global upscaling of the CCS, we see that there is a future for CCU utilizing the carbon for producing electrofuels.
Yeah, sort of an inconvenient truth out there. CCS.
It is.
We if you look at the overall things we can do, it's probably a very useful thing to do, but it's a very hard one to get accepted indeed.
Yeah. And I would like to just add also that we are definitely facing a lot of different options that we need in case to get fossil free. So methanol is one of the options, and we have said it plenty of times this day. We need a range of options that suits the long distance and the short distance, different transport modes.
Okay, thanks, Maria. Christian, any final thoughts from you?
Not really. I mean, the things that I find the most interesting right now from a technical perspective is this nice intersection between electricity and carbon capture, where you potentially can do away with pure hydrogen generation and integrate the reduction of the CO2 and do the generation of the amine or whatever capture agent you're using. So that's something that I would like to investigate in much more detail in the future.
Thanks. Ingvar, any final words to add?
I think that the key thing I got really interested in during the work we are doing just now for IRENA and Methanol Institute is this combination that the green carbon actually can be utilized so much more than I mean, I've been in this kind of thinking for a long time, but haven't really done the numbers, and it's quite realistic looking at the developments from Linde and Air Liquide, I think it is. No, it's Linde and BASF. How they do novel developments of concepts from biogas and taking the reformer in a different way, and everything is actually after this using the carbon from the feedstock in a smarter way. So with a decrease of production cost of hydrogen, I cannot see a reason why the green carbon, the green carbon from the biomass should not be utilized in the way I've showed on a couple of the slides.
One
so that's
plus
my
one
key
equal.
message.
1 + 1 = 3 in that case, I hope. Yeah.
Yeah.
Jens, over to you for a final.
Yeah, thanks. Well, I think we're in arm's reach of getting a business case together here. There's plenty of money dedicated to these things by all the governments in Europe, and it would be a shame if we don't use that opportunity and if we get stuck in discussions and policies and politics, because other regions like China, they will develop this and they will do this, and so we better get our act together and move, because technically it's done. We have all the puzzle pieces. We just need to put it together, and we need to push this forward.
Thanks. That's a strong closing statement. Thank you very much, all 4 of you.